Hello and welcome everyone. In this video, we will look at LU decomposition methods. Any square matrix A can be expressed as a product of a lower triangular matrix L and an upper triangular matrix U. There exist different methods that place different constraints on L and U. For example, in Doolittle's decomposition, diagonal elements in the lower triangular matrix are all equal to 1. In Crout's decomposition, the upper triangular matrix has a diagonal of 1s. In Choleski's decomposition, the constraint is that the lower triangular matrix is the transpose of the upper triangular matrix. We'll look at all of these three methods in detail in the coming videos. After decomposing A, it is easy to find a solution through a forward substitution process followed by the backward substitution process. LU decomposition is typically more efficient method than Gauss elimination. For example, when it comes to solving multiple systems with different B vectors, we only have to decompose A once and we can quickly use the forward and backward substitution steps and avoid the need to re-eliminate variables repeatedly, as we do in Gauss elimination method. In the next video, we'll explain Doolittle's decomposition method using a Python code and also use this code to solve a curve fitting problem. Thanks for watching and see you in the next video.